What is the multiverse? The multiverse theory suggests that our universe, with all its hundreds of billions of galaxies and almost countless stars, spanning tens of billions of light years, may not be the only one. Instead, there may be an entirely different universe, distantly separated from ours, and another, and another. Indeed, there may be an infinity of universes, all with their own laws of physics, their own collections of stars and galaxies, and maybe even their own intelligent civilizations. It could be that our universe is just one member of a much grander, much larger multitude of universes, a multiverse. The concept of the multiverse arises in a few areas of physics, but the most predominant example comes from something called inflation theory. Inflation theory describes a hypothetical event that occurred when our universe was very young, less than a second old. In an incredible brief amount of time, the universe underwent a period of rapid expansion, inflating to become many orders of magnitude larger than its previous size, according to NASA. Inflation of our own universe is thought to have ended about 14 billion years ago. A cosmologist at Arizona State University and an expert in multiverse theory. However, inflation does not end everywhere at the same time. It is possible that an inflation ends in some region, it continues in others. Thus, while inflation ended in our universe, there may have been much other, more distant regions where inflation continued and continues even today. Individual universes can pitch off a larger inflating, expanding universes, creating an infinite sea of external inflation filled with numerous individual universes. In this external inflation scenario, each universe would emerge with its own laws of physics, its own collection of particles, its own arrangement of forces, and its own values of fundamental constants. This might even explain why our universe has the properties it does. Partially, the properties that are hard to explain with fundamental physics. If there is a multiverse, then we would have random cosmological constants in different universes, and it is simply a coincidence that the one we have in our universe takes the value that we observed. The biggest piece of evidence for the multiverse is that life exists, partially intelligent life capable of making cosmological observations. Certain aspects of our universe seem special and important for supporting life. such as the longevity of stars, the abundance of carbon, the ability for light for photosynthesis, and the stability of complex nuclei. But all these features are typically not the case if you get handed a random universe. The multiverse offers one explanation for why all these features are favorable in our universe, which is that other universes exist as well. But we observe this one because it's compatible of supporting complex life. In other words, so many things had to line up just right in our universe that the existence of life seems improbable. And if there was only one universe, it likely shouldn't have life in it. But in a multiverse, there are enough chances for life to appear in at least one universe. But this theory is not especially compelling, so most scientists remain skeptical of the multiverse idea.